With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
So the question is evaluate integral of under root x square minus a square dx. Okay. So the given integration is, let's say this is equals to I. So I is equals to integral of under root x square minus a square dx. Let x is equals to a sec theta. So differentiating both sides with respect to x, we get dx is equals to a. Now differentiation sec theta is sec theta tan theta d theta. So I can be written as I is equals to integral under root. Now in place of x we write a sec theta. So a square sec square theta minus a square whole under root. Okay. Now in place of dx we write a sec theta tan theta d theta. Okay. Now this is equals to I is equals to integration of under root. Now if we take a square common, so this becomes a square into sec square theta minus 1, okay, into a sec theta tan theta d theta. Now we know that tan square theta plus 1 is equals to sec square theta, or sec square theta minus 1 is equals to tan square theta. So in place of sec square theta minus 1 we write tan square theta. So I is equals to integral of under root a square tan square theta, okay, multiplied by a sec theta tan theta d theta. Okay. Now I is equals to integral of, now under root a square tan square theta is a tan theta into a sec theta tan theta d theta. So our I is equals to integral of a square tan square theta into sec theta d theta. Now in place of tan square theta we write sec square theta minus 1. So our I can be written as I is equals to integral of a square sec square theta minus 1 into sec theta d theta. So I is equals to integral of a square sec cube theta minus sec theta d theta. Okay. Now I is equals to integral a square sec cube theta d theta minus a square integral sec theta d theta. We can take a square outside of integration because it is constant. So I is equals to a square integral. Now sec cube theta can be written as sec theta into sec square theta d theta minus a square integral sec theta d theta. Now here we apply integration by parts, in which now integration by part is first function into second function. Integration is equals to first function into integration of second minus integral of differentiation of first function into integration of second. Okay. Now here we let this function is first and this is second function. So I can be written as I is equals to a square. Now first function, which is sec theta, into integration of second, so integration of sec square theta d theta minus integral of now d by d theta of sec theta into integration of sec square theta d theta whole under d theta. Okay. Minus a square integral sec theta d theta. So our I is equals to a square, now sec theta. Okay. Now integration of sec square theta is tan theta minus integral of, now differentiation of sec theta is sec theta tan theta. So sec theta tan theta into integration of sec square theta is tan theta, so into tan theta d theta. Okay. Minus a square sec theta d theta. Now our I can be written as a square sec theta tan theta minus a square integration of sec theta tan square theta d theta minus a square integration of sec theta d theta. Okay. Now this is equals to a square sec theta tan theta minus a square. Now in place of tan theta we can write, in place of tan square theta we can write sec square theta minus 1 d theta minus a square integration sec theta d theta. Now this is equals to a square sec theta tan theta minus a square integration of sec cube theta d theta minus minus plus a square integral sec theta d theta minus a square integral sec theta d theta. Now if we see the terms plus a square sec theta integration sec theta d theta cancelled by minus a square integration sec theta d theta. Now if we see, our I is equals to integration of a square sec cube theta minus of a square integration sec theta d theta. So in place of integration of a square sec cube theta d theta we can write I plus a square integral sec theta d theta. So in place of a square integral sec cube theta d theta we can write I plus a square integration of sec theta d theta. So I is equals to a square sec theta tan theta. Now in place of minus a square sec cube theta integral we can write it as minus of I plus a square integral sec theta d theta. So from here we get I is equals to a square sec theta tan theta minus I minus a square integral sec theta d theta. Now if we take minus I to the left hand side, this becomes 2I is equals to a square sec theta tan theta minus a square integral sec theta d theta. Now we know that integration of sec theta d theta is equals to log of sec theta plus tan theta. So by using this we can write 2I is equals to a square sec theta tan theta minus a square log of sec theta plus tan theta plus c. Okay, or I is equals to a square by 2 sec theta tan theta minus a square by 2 log of sec theta plus tan theta plus c, where c is the constant. Okay, now initially we assume that our x is equals to a sec theta. Initially we assume x is equals to a sec theta, and we also know that 1 plus tan square theta is equals to sec square theta, or tan square theta is equals to sec square theta minus 1, or we can write tan theta is equals to under root of sec square theta minus 1. So in place of tan theta we write under root of sec square theta minus 1. So our I can be written as I is equals to a square by 2 now sec theta, and in place of tan theta we write under root of sec square theta minus 1 minus of a square by 2 log of sec theta, plus in place of tan theta we write under root of sec square theta minus 1, okay, plus c. Now in place of sec theta, from here we get sec theta is equals to x by a. So in place of sec theta we write x by a. So this is equals to a square by 2 into x by a under root of x square by a square minus 1, okay, minus a square by 2 log of, now in place of sec theta we have x by a plus under root of x square by a square, okay, minus 1 plus c. Now this is equals to a square x divided by 2a. Now if we take LCM here, this becomes x square minus a square. Now under root a square becomes a outside of under root minus a square by 2 log of, if we take LCM here, x by a plus under root of x square minus a square divided by a, because under root a square is a. Now a into a cancelled a square, so this is equals to x by 2 bracket of under root x square minus a square, okay, minus a square by 2 log of x plus under root x square minus a square whole divided by a plus c. So this is equals to I. So the integration equals to x by 2 under root of x square minus a square by 2 log of x plus under root x square minus a square by a plus c. Okay, thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.